My name is Hunter Finney from the University of Utah. I'll be presenting our poster about navigational cues inside an immersive virtual environment. The two research questions we're going to be looking at are: how do navigational cues help develop spatial knowledge of a virtual environment? And do these cues in the environment affect cognitive load in the process of navigation? In order to evaluate these questions, we're using an HTC Vive Pro I and a virtual city to navigate inside of. We're also using a detection and response task, a DRT for short. This device is affixed to the participant's clavicle and will vibrate sometime between 3 and 5 seconds. You can see how this is attached in our picture to the left. Once the DRT vibrates, the participant will push a button. The response time as well as accuracy will measure cognitive load. In our experiment, we used a within-subject design with 15 participants, where participants navigated in 2 different virtual cities and 2 cue conditions. Both these were counterbalanced. So here's a short video describing the method we used. Participants are seated the whole time in a rotating chair and will have to rely on a controller to navigate. They start off in practice city to get familiar with the locomotion method and virtual reality. They will also take some time to adjust to responding to the DRT. Once training is over, they're instructed to find 3 main targets throughout the city. Each target is presented to them one at a time. Subjects are able to use multiple cues to help navigate. For instance, here we see the cues on condition with a compass, street name, and overlay markers for found targets. Notably, both conditions are able to use a GPS-like map that will update the position as they navigate. However, we can contrast this with the cues off condition in a similar area shown here. Once a participant finds all 3 targets, the next task is to return to the starting location at the beginning of the search task. At the starting location, the DRT and all the cues are turned off, and the participant is then asked to point at the main targets and home from each target. The process is then repeated days later in a different city with a different cue condition. So let's take a look back at our research questions. Do cues help develop spatial knowledge? The answer is no for this experiment. The pointing error across cues and no cues showed no significant difference. However, order suggests that there's a difference between first session and second session. We find that the first session that the subjects had scored a higher error regardless of the cue condition that they're in. For our next question, do cues increase cognitive load during navigation? Also no, but it actually reduced cognitive load. We found significant differences in response times for both location and condition. Here you can see how intersections are much slower than street response times. And you can also see how having cues on reduced response times in both locations. I found this really interesting and decided to look at how long participants spent looking at the map. Here's a graph showing how long people look at the map by percent time they are in the environment. So the map is a powerful cue and requires a lot of cognitive load to use well. We found that when the cues are off, participants spent significantly more time looking at the map. So let's quickly go over some conclusions we can draw from this data. The over-reliance on the map in both conditions may have decreased the effect of cues had on participants. Also, even though our participants' visual field is just bombarded with information with these cues, response time is actually faster than not having it. This leads us to believe cognitive load is reduced by having these cues. Participants might be able to offload information that they would have needed to hold in their memory otherwise. Interested in what steps we're taking in continuing this work, please come by our poster and chat with me. I would also like to thank the Natick Soldier Systems Center for the support they give to us to make this research possible. Thank you all very much for listening.